All right, for this last video, we're just going to do some Punnett square problems just to make sure that you all are comfortable with how to set them up and how to answer questions about them. In the last video, I proposed the cross of a woman who was a carrier for the colorblind allele and who was homozygous for being able to roll her tongue, with a man who was colorblind. Now, how do we know he's colorblind? Because he has the recessive allele for normal vision, okay, little n. And the man also could not roll his tongue. And so the first thing we need to do is complete the Punnett square. And because this is a dihybrid cross, meaning we're looking at two traits together, colorblindness and the ability to roll the tongue, then we're going to have to do a 4x4 square. So we're going to put Dad's gamete possibilities across the top. So in his sperm cells, he could donate an X with a little r, or X with the other little r, or Y with a little r, or Y with the other little r. Mom could donate X, big N, big R, X, big N, little r, X, little n, big R, or X, little n, little r. So if you didn't already do this cross in the last video, I want you to pause the video, fill in the Punnett square, and then come back and we'll work through it together. Okay, so now that the Punnett square is complete, let's answer some questions. Okay, so of their children, how many would we expect to be colorblind? Okay, now this is out of the entire 16 possibilities here because we are talking about all of the children. Okay, so let's combine it with how many would we expect to be colorblind and not be able to roll their tongue. Okay, now in order to be colorblind, they have to have, if they're a female, they have to have 2 little n's. If they're male, they just need 1 little n. And if they can't roll their tongue, then they need 2 little r's. Okay, well, if we look through the first 2 rows, all of these potential offspring have at least 1 big N. Okay, so none of them are meet our criteria of being colorblind and not being able to roll the tongue. In the 3rd row, all of these potential offspring have at least 1 big R, so they all can roll their tongue. But if we look at the 4th row, both of the girls have 2 little n's, and all of the offspring have 2 little r's, and the boys have a little n. So of the children who would be colorblind and non-rollers, 4 out of 16, we would simplify that to 1 out of 4. So for this particular couple, every time they have a child, there would be the probability, a 25% probability or a 1 out of 4 chance that they would have a child who is colorblind, who could not roll their tongue. Now, what if instead of wondering about all of the kids, we just wanted to know about the girls? What's the chance that a daughter would be colorblind and a non-roller? Okay, well, the boys are on this right-hand half of the square, so we can ignore that for right now. So our daughters who are going to be colorblind and non-rollers are going to be those bottom 2 left squares. So it's going to be 2, but 2 out of how many? 2 out of 8, okay? Because out of all of the possibilities, only half of them can be girls, okay? So if we simplify that, we still get a 1/4 or a 25% chance, right? If they have a daughter, so the baby's born, it's a girl, or they do an ultrasound, they know it's a girl, there's a 25% chance that she's going to be colorblind and not be able to roll her tongue. The boys would have the same possibility, okay, based on this particular chart. Okay, let's do another one, but this time let's just think about Mendel's P's. Okay, so let's go back to having a white or a flower with white, a plant with white flowers, and heterozygous for round seeds being crossed with a heterozygous purple flowered plant who is also heterozygous for round seeds. Now, you may be wondering, why don't I have X and Y's here? The reason is because flower color and seed texture are autosomal traits. They are not carried on the sex chromosome. So we don't have to worry about X's and Y's unless we are doing a cross involving the sex chromosomes. Okay, so I just want to be really, really clear about that. Okay, so let's set up our square. Okay, we're going to put the gamete possibilities for this first parent down the side. Okay, well, this parent only has little p's. So the first little p could sort with the big R, or the first little p could sort with the little r. Remember, this is all about independent assortment during anaphase 2 of meiosis 2. Okay, or the second little p could sort with big R, or the second little p could sort with the little r. Now, for our second parent, big P, big P could sort with big R, or big P could sort with little r. Little p could sort with big R, or little p could sort with little r. Okay, and I'm going to leave you to fill in the square and, kind of play around with it. But I do want to give you a couple of tips, okay? If we wanted to know of these offspring, how many could be purple, we look, and the only place that we see big P's are right here. So these two columns are the only places that we could have purple flowered plants. Well, what if we wanted to know how many plants with purple flowers and wrinkled seeds. Wrinkled is the recessive, so it would have to be 2 little r's. Well, if the plants have purple flowers, we know we're in the first 2 columns. If they have wrinkled seeds, we know they have to be little r, little r. Little r, little r, that would be one of them. Little r, that would be one of them. We don't have to worry about the rest of them because we specifically asked about purple and wrinkled. Okay, so of the possibilities, of the 16 possibilities, what percentage would we expect to be purple and wrinkled? 2 out of 16, or 1/8, which is, what percentage is that? I should know that off the top of my head, but I don't, like 12.5%. Yeah. So we would expect 12.5% of the offspring from this cross to be plants with purple flowers and wrinkled seeds. Okay? All right, so after you go through this video, if you have questions about working Punnett square problems, definitely reach out to me. When you are taking the final exam and you're reading the questions about Punnett squares or about genetic crosses, make sure that you are paying attention to words like autosomal, sex-linked, you might, I'll try not to do this, but if one slips through, there might be something that says non-autosomal. Well, if something is not autosomal, then it has to be sex-linked. So those 2 things are synonyms. And then just pay attention in the question to how the population of interest is defined in the question. So are we talking about all of the offspring? Are we talking about what percentage of the girls? What percentage of the boys? What percentage of a certain subset of the population has this other characteristic? Okay, so you just have to pay attention to how those things are worded in order to get the right answers. I will be on Blackboard tomorrow, Wednesday, during office hours from 10 to 11. I will not be available on Friday due to capstone proposal day in the Honors College, but if you have any questions, feel